Okay, here we go with the 1.2 respiration and the respiratory system test. So, first question, the diagram shows the chest in a human, so label A and B. So the A was the trachea. We're not going to accept windpipe because let's just go with trachea. And then the B was the alveoli, so these little bits, if I zoom in there, you can see that they are looking at those little cauliflower, those little fluffy cotton wool bits at the end. And then it says, describe the movement of the diaphragm of the ribs as they bring about an increase in volume. Well, if we're going to increase the volume, we need to contract this diaphragm, and it'll move down, it'll flatten, and also the ribs will expand. So the ribs will expand and move up and out. What that will do is increase the volume inside that chest cavity. And if we do that, then the pressure, which I think is the next question, the pressure is going to decrease on those lungs, enabling it to inflate. So how does the pressure in the lungs change when this volume increases? Well, the pressure is going to decrease. There's going to be less pressure on those lungs. Question 2 then brings us to the alveoli sort of question, and it says label parts M. It's not the bronchus, even though it looks quite thick. The bronchus is way up here, somewhere up in the, you can't even see it because there's no diagram. The bit just before the alveoli is called the bronchiolus, or the bronchiole, just singular. So just be careful there not to put bronchus, bronchiolus. I know they're very similar sounding, but we've got to be very careful. Name gas Y. Well, it's either going to be oxygen or carbon dioxide because that's the gas exchange that's happening. It's moving out from the blood supply, or I should say from the plasma really. It's not showing any blood cells there. So if it's moving out, that means our body's getting rid of it, therefore it's a waste product and it's carbon dioxide. Explain how this gas X, so the gas X is going in now, is getting into the blood capillaries, the blood supply. Well, it's by the process of diffusion. So there's a higher, obviously, when we breathe in and bring in that air, 21% oxygen, there's a higher percentage of oxygen inside the alveoli than in the blood supply, because obviously we've delivered blood all around our body, delivered oxygen all around our body, so it's coming back oxygen depleted, so it's going to pick up that oxygen through the process of diffusion. So it's moving from an area of high concentration to an area of low concentration there. Complete the table below with the differences between inspired and expired here. So that's the air that we breathe in and the air that we breathe out. So the air, the atmosphere contains 21% oxygen. When we breathe that in, we use 5% and we breathe back out 16%. So we don't use all the oxygen in the air. We breathe in 0.04 carbon dioxide, but because of respiration and it produces carbon dioxide, we breathe out 4%. And then nitrogen, we can't use nitrogen in the form of gas, so that stays the same. And water vapor, yeah, it does vary, depending on where you are. Question 3 then. The diagram below shows a human respiratory system, label parts A, B and C. So if I just zoom in, A is definitely a rib, it's the white bit. B is definitely the trachea, and we're going to go with trachea, not windpipe. And then C is the bronchus, before the bronchiolus, or the bronchies, yeah? This is the bronchus. So I think I've done that there. And then on the diagram above, name, so this is where we're looking at, name the structure that contracts when we inhale. Well, that could be one of two things. So let me move back down. That could either be the diaphragm that contracts, flattens out, okay, to open up this chest cavity to increase the volume, or these intercostal muscles actually contract and push out, again opening up this chest cavity to allow this air to flow into the lungs, yeah? So there's less pressure on these lungs then. And that's that question. 2 marks. The next one, the diagram below shows the alveolus in a section together with a blood supply. So the blood supply is, it doesn't show the direction, but it doesn't matter really. Gas exchange takes place in the alveolus and the blood state. The process diffusion from an area of high concentration to a low. Describe 2 adaptations of the alveolus to help gas exchange. Well, I've put 3 here. It's got a large surface area, yeah, that's why they sort of cauliflower out when you look at them under a microscope. So they do sort of bulb out, increasing that surface area. They're only 1 cell thick, which allows easy access for diffusion then, okay? It's not got much to go through. And then they are moist. I think gas exchange is best when it's when they're moist, okay? So that's all you got to remember there. So large surface area. It's only 1 cell thick. You can put thin. It's got a thin wall. Don't use wall, by the way. It's got a thin membrane and it's moist. So let's get rid of that there. And then on to question 4. It's probably, in my opinion, the hardest question on the paper. It says the graph below shows efficiency of the lungs. Well, how well they work, so efficiency, in 3 different groups of people. So you've got non-smokers, smokers, and people who stop smoking at the age of 50, and heavy smokers. So there's our keys. So the thicker dotted line is the non-smokers. That's this one coming down. You've got the thinner dotted line, which is the smokers that stopped at the age of 50, and it sort of tails off there. And then you've got the heavy smokers that just keep smoking away. It says, what is the difference in percentage efficiency of a 60-year-old non-smoker and a 60-year-old heavy smoker? So we're comparing. So 60, you can't see it very well here. If I zoom in a little, you can see that I've gone up with a ruler and I've drawn a line between there and there because that's my heavy smoker. This is my heavy smoker. So at the age of 60, that's my heavy smoker. And at the age of 60, this is my non-smoker. So really, I want to know the difference. If I get the highlighter or a pen, I've never used this before. Is there colours? Let's have a look. Highlighter. No, I was using a rubber then. Sorry. I want to know the difference between there. So if I go back now, I've drawn a line across there, and that comes out to be 48 because every square is worth 2. So there's 5 squares between 40 and 50. So each square is worth 2. And I've drawn a line across there, which is I thought was 92. The mark scheme is quite flexible. I've said 92 minus 48, which is 44. But the mark scheme will give anywhere between 44 and 46, depending on where you've drawn your lines. So if your lines are fairly accurate, then you're going to come out with somewhere between 44 and 46. Continuing to smoke heavily can damage the lungs and lead to disability. At what age does the graph show this disability occurring? Well, if we look at the graph, it says there, percentage lung efficiency causing disability. That's this line here. So if we just trace this line back, and then heavy smokers, it's going to be around about 66. So that's why it's 66 there. Suggest what the lung damage mentioned in question 1 could be. Well, any lung damage, the top answer for lung disease really is a lung cancer and emphysema. The emphysema, those are your top answers for that one. Susan is a 50-year-old smoker, heavy smoker. Use the graph opposite to suggest what Susan might expect to happen if she gave up smoking now. So she's 50 years old and she wants to stop smoking. What could happen? So let's go back to that graph. She's a heavy smoker. Once she's 50, okay, the heavy smoker, she's going to take this path. So anything really, she could have less chance of a disability and less chance of dying early really. So it's going to increase her life she's going to live longer, till about 85. Let's have a look. That's on the graph. So I'm just pointing that out there. That's why I've put 85. So she's definitely got an increased chance of living longer, without a smoking related disease there. So fairly common sense, just getting it from the question for 2 marks. Which brings us nicely to our last question, and this is a 6 marker. The diagram below shows a section through the chest. It's labelled it up ready for us. Use the above diagram and your own knowledge to explain how air is drawn into the lungs during inspiration, breathing in. So I've got 1, 2, 3, 4, 5, 6 sort of good bullet points to use. Obviously wrap this up in a paragraph. First thing I've said is the diaphragm contracts, okay? It flattens out and it moves down. So this is going to contract. The intercostal muscles is going to contract and move outwards. That's going to open up the chest, increase the volume. The volume in the chest is going to increase. Therefore, the pressure on the lungs is going to decrease, okay? Allowing the lungs to inflate as air is drawn in to the lungs via the trachea. And that is pretty much your 6 marks right there.